Good afternoon. Welcome back, everyone. What a great poster session that was. Almost 40 posters. Great effort. Well done. Welcome to a fascinating afternoon of science. Hope you're refreshed. And we're going to continue our focus on key priorities for our seas and oceans with a series of talks on biodiversity and climate change. Now, both of these themes figured quite strongly in David Attenborough's presentation to the G7 at the weekend. I'm sure you saw some of the media coverage of it. And it's interesting how we used our response to the COVID pandemic to highlight just how much the science community can achieve with a common purpose. And so that's a challenge for us when tackling the biodiversity loss and climate change priorities. So let's look at how our partnership working has had a global impact and get straight on with our talks in this session on biodiversity. First, we'd like to introduce Aria St. Louis. Who's the head of the Environment Division in the Government of Grenada. Aria has worked with us on seabed habitat mapping projects around the islands and also done really valuable work on resilience to climate change. So we'll start the session with Aria's talk, and then we'll follow that with our Cefas scientists, Paul Wamsley, Elena Cucci, and Chris Lynham. So, Aria, over to you for your talk.
Thank you, Chair. Good morning, good day, good evening to fellow panelists, scientists, colleagues. It is a pleasure for me to participate in today's event. At the outset, I would like to thank the organizers for this opportunity to present on the productive collaboration between the Environment Division, Government of Grenada, and the Center for Environment, Fisheries and Aquaculture Science of the UK Government, with a collection of important primary data from the nearshore marine environment in support of effective ecosystem management and decision-making, and a transition to a blue, resilient economy. Today, I want to give you a context and then briefly identify some milestones in research carried out through our collaboration to address key issues and provide needed data to answer some important questions to inform policy and decision making. I will then share some lessons learned. So at the global scale, the United Nations General Assembly has declared the next 10 years the decade of ecosystem restoration. The UN has also declared a decade of ocean science for sustainable development. This seems to be setting the stage for a concerted effort between humans and the environment to support sustainable use. So globally, we are seeing a commitment towards sustainable use of natural resources, resulting in an emerging green and blue economy thrust. At a national level, Grenada is a small volcanic tri-island state in the Caribbean Sea. It is 133 square miles and, as you see, close to South America with 100,000 people. Like other small island developing states, Grenada shares certain challenges and vulnerabilities which can constrain investment in resilient development and can challenge growth prospects. Overdependence on imports, fragile open economies, acute vulnerability to natural disasters, to impacts of climate change, and to drivers of biodiversity loss, limited opportunity to access finance, and heavy dependence on tourism and the fisheries sector are some of the challenges and vulnerabilities which Grenada shares as a tri-island state. Like many other SIDS, we are facing one of the greatest challenges to our economic health and survival. The COVID pandemic has had a devastating effect on small island nations, not just in terms of loss of livelihood, but also the dividing of limited government financing to support the slump in tourism sector and associated economic activities, for example, the restaurants, the bars, the taxi service, etc., as well as the fisheries sector that has also been hard hit, as a lack of air and shipping transport, as well as closed borders and lockdown conditions, affect major restaurant chains and the ability to export fish to our usual markets. There is also the huge strain to support the health sector and provide social support to the most vulnerable. This has created an urgent need to diversify, expand into new areas of possible economic activity, including resilient blue economy. In Grenada, we have recognized the critical need to diversify our economy away from an overdependence on traditional sectors like tourism and fisheries. And there were three main reasons or factors that influenced this focus. One, as small island developing states with an economy of scale, greening the entire economy would be possible in a way that just wouldn't be possible for a larger economy or a larger country. That is to say, Grenada is more like a microcosm for greening across all sectors and program areas, including promoting growth in traditional, existing productive sectors, as well as investing in new and high-value blue economy industries. A second factor which influenced the focus on blue economy early was that Grenada, as an archipelagic state with extensive marine territory, that is, its EEZ, is 78 times larger than the land size, with potential opportunities ranging from hydrothermal vents and mineral-rich water to fish stocks and a dearth of living resources. These offer tremendous opportunities for economic and social development and also provide for sustainable livelihoods. A third main factor which influenced this focus was that finally we knew that we had to pursue the use of natural and living resources through ecosystem-based management and nature-based solutions, as we did not have the budget for expensive research and technologies to address serious challenges posed by climate change. That is to say, the cost of building and maintaining a seawall versus maintaining wetlands and planting coastal vegetation to reduce erosion made it easy as a factor to focus on blue economy, and ecosystem-based management fits very well in with the blue economy thrust because the healthy ecosystems underpinning blue economy assure us sustainability. So in this light, Grenada's blue economy is described as a sector that maximizes the economic value of marine resources while protecting and managing these very same resources and ecosystems for future generations. In 2013, Grenada adopted the Eastern Caribbean Regional Ocean Policy and Action Plan. In 2015, with growing concerns of coastal erosion and slow onset events like sea level rise, the Environment Division collaborated with Cefas to carry out an assessment of 20 selected embayments across the Tri-Island state. The purpose was to characterize and better understand which beaches were high energy, medium energy, and low energy, with a view to collecting baseline data to begin to understand what was happening with our 20 beaches. Questions about whether they were stable, accreating, or eroding, and how best to tailor management plans lay at the heart of the decision making and the policies and management for which we needed good quality data. The collaboration at the time was part of identification of climate change adaptation strategies aimed at the community level. So as part of the work, a sediment transport study was carried out in low-lying vulnerable coastal areas to inform the options to address storm surge and coastal erosion in those areas. The sediment transport study was the start of a productive relationship between Grenada and Cefas that influenced the update of a key policy document, Grenada's Systems Plan for Parks and Protected Areas, to consider and include a number of key embayments, for example, Conference Bay, where management plans were built upon the work done by Cefas and Environment Division. While the size of Grenada's marine space provides an excellent opportunity for blue economy, it poses significant challenges for management, conservation, and development of the resources within its exclusive economic zone. Recognizing the need to manage our nearshore coastal resources and to enhance marine biodiversity, in 2016, Cefas commenced Project Neptune in collaboration with the Government of Grenada. This, in fact, was a collaboration between the UK National Ocean Centre, Cefas, and the UK Hydrographic Office and the Government of Grenada, and included Ports Authority, Environment Division, and Fisheries as the main focal points and partners. This was the precursor to the Commonwealth Marine Economies Programme, which continued to work in follow-up to Project Neptune and resulted in seabed mapping for improved charting and environment management, which had implications for some of our key multilateral environmental agreements and compliance with these agreements. Among other activities that took place between 2017 and 2021, I recall the marine benthic habitat mapping, which was used in the designation of our largest and most recent marine protected area, the Granans MPA, and its associated management plan. In addition, under the CME program, bathymetric work resulting in the update of naval charts, which themselves were used to update shipping channels and plot our marine spatial plan, has resulted in the update of our Blue Growth Master Plan in 2021. Invasive species risk assessment, vulnerability assessments, and a blue carbon assessment have also been carried out in collaboration with Cefas between 2017 and 2021, with associated equipment advice and procurement, and capacity building in coastal monitoring activities. As a result of the collaboration, a number of young Grenadians working in Environment Division have benefited over the last 5 years from exposure and training in coastal nearshore marine monitoring, as key primary data sets were collected. This allowed these young persons to gain experience in equipment use and robust methods that have resulted in a number of them going on to do graduate degrees in aspects of coastal and marine conservation and management, and returning to Grenada to support our transition to blue economy. During this time of collaboration with Cefas, Environment Division had an opportunity to set up a coastal zone portfolio within the division. And this slide, I take a few seconds just to focus on this and the importance to a small island state of its coastal zone, and therefore the importance of the collaboration. Not only did we focus on coastal zones specifically and within the division, set that up as its own portfolio, but we set up a coastal zone task force whose capacity was built through the collaborations that we had with Cefas, and where regular updates and sharing of the data was done to help bring an appreciation and an understanding of the importance of good quality primary data to a key group of persons. Key policy documents prepared included Grenada's first ever coastal zone policy, which was informed and fertilized by primary data collection taking place in the nearshore marine environment and the habitat mapping work that has commenced. In particular, at vulnerable embayments that had been characterized under the original sediment transport study in 2015, community groups have now embarked on restoration activities, including mangrove replanting, diversifying livelihood options to include ecotourism tours and visits to the restored areas, and also mangrove honey farming and sea moss farming or mariculture. Just a few lessons learned through collaboration with Cefas. The first is the importance of an integrated approach. It was really helpful and useful as Environment Division, and we have a key role as coordinators to work along with important line ministries and to share readily with them the primary data that was collected by Environment working along with Cefas. We found, therefore, that we got maximum value and maximum usage of the data sets through an integrated approach. Secondly, a whole of society buy-in was identified as key. And here I want to highlight that I think very early on, we had the political buy-in for the need to transition to a resilient blue economy. But what we wanted to make sure was that it wasn't only just within government, but also at the grassroots level that we had buy-in and an understanding of how the collection of primary data would help to inform sound decision making. This ties very closely in with point 3 under lessons learned, which was sustainability can be built through community ownership. So once we had taken time to include community, it meant that there was a sense of ownership built within community. And this then meant that the activities that were taking place were not just pushed by government and stopped as soon as government was no longer there. There was community ownership and buy-in, and through that, sustainability. The fourth lesson that we learned was that it's really important to make it scalable, meaning that we realized that planning and collection of data needs to happen, and for us, primarily at the level of the community. Yes, we could replicate, and yes, we could scale up, but it was really important to make sure that we were balancing this very carefully and making good decisions at the level of community with respect to incorporation of community in the data capture and in the understanding of how the primary data was going to inform decision making. Finally, I want to extend special thanks to the hardworking staff of Cefas who learned how to expect the unexpected. Whether it was a storm that blew in when the plans were to head out and collect data on what seemed to be an idyllic day, or it was the government restructuring for wise fiduciary management, which led to changes and reconstitution of various ministries, changes in the permanent secretaries, and changes in the physical location of the Environment Division. We continued to maintain strong collaboration and to work closely along with our partners in Cefas. With respect to the next steps, post-COVID, Grenada is ideally positioned to transition to a resilient blue economy. We now have in place our updated Coastal and Marine Spatial Plan, our Ocean Policy, and an Ocean Governance Committee. We also have attracted resources through the OECS and through other partners who we continue to work with, and we bring these now to the table when we continue our collaboration with Cefas and the technical support that they kindly provide to us. So under the biodiversity portfolio, we will be continuing the habitat mapping with various community groups. We also will be doing activities with the Nature Conservancy at the Water's Edge project and the Resilient Islands Initiative. I want to also say a special word about Grenada's National Ecosystem Assessment because we will be the first island globally to participate in its own national ecosystem assessment using the IPBES methodology. And in fact, this Friday, our zero draft is due. And we have benefited from the assistance of members of the Cefas staff family who have given support to one or other of the 7 chapters, either in reviewing or being an contributing author, but we are delighted to continue that partnership and work with Cefas. And then in our climate change portfolio, we are looking forward to an upcoming consultation on marine renewable energy. So I now come to the end of the talk where I thank you so kindly for your time and attention, and I look forward to any specific follow-up.
Hello everyone, my name is Dr. Paul Woolmsley. I'm a marine ecologist working here at Cefas. Today I'm going to take you on a whistle-stop tour to describe why marine protected areas are important and how they are created. Biodiversity loss is a major issue affecting marine ecosystems around the world. Thousands of species are characterised as endangered. Marine ecosystems that provide habitats for these species and the livelihoods for billions of people around the world are also under threat from human activities and climate change. Marine protected areas are an important tool that help us to protect and conserve marine habitats and species, therefore reducing biodiversity loss. Marine protected areas also help us to sustainably manage these areas and therefore preserve healthy and resilient ecosystems. Many factors must be considered when creating a marine protected area. These include design. This is crucial to ensure that the marine protected area is created in the right location so it offers the protection needed for key marine habitats and species. Once designed, the MPA must be legally designated as a marine protected area. This involves legislation being produced and written into law that allows the area to be actively managed. Once designated, it is vital that management is put in place to ensure the marine protected area effectively meets its many conservation, social and economic based objectives. Finally, the area needs to be protected and management strategies enforced. This is important as it ensures that habitats and species are protected from activities that could have negative impacts on the area. Examples of marine protected areas recently created through the UK Government Blue Belt programme are the Ascension Island MPA, created in 2019, that covers 440,000 square kilometres, and the newly created MPZ around the Tristan da Cunha archipelago that is almost 3 times as large as the UK. Thank you for listening and enjoy the rest of the conference.
Hello everybody, my name is Elena Couce and I'm going to talk about predicting biodiversity for our changing oceans. So you've just had a talk about how important biodiversity is, and the loss of marine biodiversity is actually affecting the ocean's ability to withstand perturbations and to adapt to climate change. which is making it risky for them to play the role as a climate and ecological regulator for the planet. One way of looking at it is using species distribution models. And these are models that relate the distribution of a species with the environmental characteristics of their habitat. Okay, so in this case, for example, the native oyster, you have the distribution of the native oyster around the UK waters, and then you have all the parameters that you think explain why the species is there. Things like temperature, like how deep the water is, what is the composition of the bottom? Do you have sand? Do you have rocks? Things like salinity. And so species distribution model puts these two things together and actually creates a prediction of the habitat of the species based on the characteristic of the environment. Okay, so this is the prediction we get for the oyster. And the yellow-green colors is like a suitable habitat, and the dark purple is a non-suitable habitat. So you can see that it more or less matches the distribution of the species. But the interesting thing is that once you have trained the model, instead of giving it the present day conditions, you can actually give it future conditions or what you think the conditions will be like in the future. And then it will give you a prediction of what the habitat for the species will look like in the future. Okay, so in this case, you see for the 2099, that decade, the oyster has extended farther north and is found in places that it is not found today. That's the prediction. So how can this help us look at biodiversity? Instead of modeling one species, we can model hundreds of species at the same time. And that can give us an idea of how the whole biodiversity, the whole number of species in each place is going to change. It's likely to change in the future. So in this case, this is an example of some work we did recently looking at marine food webs. So we modeled 200 different fish, okay? And we divided the fish in three groups: the ones that eat plankton, the ones that eat little animals on the bottom, and the ones that eat fish, the big ones. And you can see how the abundance of these fish are going to change by the end of the century under high emissions scenario. And so you can see that the plantivores are going to increase almost everywhere, and values close to 200% increase, so very big increase. The ventivores are also increasing in most places, but not as much, only up to 100% more or less. And piscivores are in fact going down in many places. So this tells us that actually it's changing the balance of the food web. How the animals interact with each other is likely to evolve in the future. Thanks a lot for your attention. This was just a little example of some work we've recently done, but there is a lot more going on. And I hope you enjoy the rest of the conference.
I'm Chris Lynham, and I will introduce some of the work we do to support an ecosystem-based approach to management and enable managers to mitigate and minimize threats to biodiversity. Human activities, such as harvesting of fish for food or the construction of turbines, can clearly impact on marine life and habitats. But indirect impacts can also alter ecosystem productivity. For example, impacts can arise from industrial carbon emissions and nutrient runoff from agriculture. Our UK Marine Strategy Regulations and recent Fisheries Act put in place an ecosystem-based approach to fisheries management to account for and mitigate the risks posed by human activities and thereby protecting species, habitats, and ecosystem function. Through our international work within ICES and OSPAR, we have identified many species that are sensitive to depletion by fishing. Where evidence arises for the ongoing depletion of species, additional work is required to understand where risks occur and where protections are needed. In the example shown, the non-target species of Atlantic wolffish has been found to be retreating over much of its range, and in the North Sea, this has led to substantial declines in UK waters that have been exacerbated by warming temperatures. To maintain and restore the diversity of sensitive species, from cold water corals to harbour porpoise, reductions in bycatch and/or protections for essential habitat are required. We have also developed a suite of simple, community-based indicators that capture the wider risks of fishing on the diversity of fish. The example here shows how a species composition metric, the mean maximum length of demersal fish, relates to the risk of depletion of species as evidenced by food web modelling. The underpinning logic is that species with large ultimate body size are typically depleted more rapidly through fishing than smaller, often more productive species. So the impacts of fishing and risk of species depletion can be monitored through our scientific surveys that sample a wide variety of species. These indicators and many others can be found on our marine online assessment tool pages, and together they capture changes in pressures and biodiversity. Overall, we have found that contaminants are low and within safe levels in both the water column and in seafood, and a good status has been achieved in terms of eutrophication. However, many issues are still present, including some depleted fish stocks, and although there are signs of recovery in fish communities, the lack of good status may be contributing to the ongoing declines in seabird breeding success. Great progress has been made in developing these assessments and in implementing measures to tackle risks from human activities, but the journey is not yet complete. We are now entering the next cycle of assessments, and with time we should see improvements in the marine environment. Thank you for listening.
Thank you to all those speakers for the great talks. There's some strong themes there, weren't there, about long-term environmental effects, and those prepare us very nicely for our fourth and our final session on climate change. So to kick off the session, we'd like to introduce Stephanie Martin. Now, Stephanie's an Environmental and Conservation Policy Officer for the government of Tristan da Cunha. She's worked with us on various projects, contributing to the Marine Climate Change Impacts Partnership report card for the overseas territories, as an expert for the South Atlantic, and she's also taken an active role in several other Blue Belt project activities. Stephanie's going to talk about evidence-based science and climate change in the overseas territories. She's going to be followed by Arian Kettle from the JNCC, talking to us about native oyster ecology, and then our Cefas scientists, John Pinegar and Bryony Townhill, will present their work as well. So, Stephanie, tell us about your work in the overseas territories.
Hello, my name is Stephanie Martin. I work for the government of Tristan da Cunha as the Environmental Policy Officer. I am presenting today as a steering group representative for the UK OTs in the Blue Belt program. The presentation is Evidence-Based Science and Climate Change in the UK Overseas Territories. I will discuss Cefas projects that have worked with the OTs, including the Marine Climate Change Impacts Partnership, or MCIP, and Cefas's coral report cards in Pitcairn and the British Indian Ocean Territory, or BIOT. Here's a map of the UK's overseas territories showing different regions and ocean basins, and each is unique, but they also have common challenges with climate change impacts. They have the equivalent of 94% of known endemic British species, with rich biodiversity, and each has a strong cultural identity. Recently, some of us have gotten a bit more attention as being on the green list, even though you still can't travel to most of them. The UK overseas territories are a diverse group, but as most are small islands with large ocean provinces, they share many common vulnerabilities to climate change, including fish and fisheries, which are locally important for food and recreation. Many of these important species and the habitats that support them could be at risk from climate-driven changes. Many of the OTs are relatively or very isolated and rely on maritime transport for access and movement of goods and people. In some of the OTs, food security relies on maritime transport. With changes in extreme weather and sea level rise, there are impacts to this important sector. As small islands, they are vulnerable to the effects of sea level rise and erosion, which may affect coastal infrastructures and land uses. They also share many similar issues when assessing the impacts and risks associated with climate change, including lack of resource for focused climate work, and this has a knock-on effect which causes difficulties in maintaining long-term monitoring, which results in large data gaps when assessing whether the changes observed in the OTs are caused by climate change drivers. Looking at future impacts is often hampered by lack of downscaled models, meaning that predictions are often based on global models. And historically, the OTs are prone to being overlooked in climate change assessments. This is the first project that the Marine Climate Change Impacts Partnership, or MCIP, is working with the UK OTs. At the heart of MCIP is its science policy interface model, which is summarized in a paper by Frost et al. In 2017, and it places emphasis on trust, integrity, and independence. The partnership comprises government agencies, NGOs, research organizations, and was established in 2005 to address the requirements for a more efficient pathway from science to UK policymakers for marine climate change research. The main function of the partnership is to bring together experts to generate a consensus view on marine climate change impacts, delivers its evidence via easy-to-read report card style summaries. These summaries are created from key messages drawn from more detailed scientific reviews, which act as supporting documents. As stated before, for the first time, MCIP is working internationally. Recognizing there is currently a lack of climate change work focusing on the OTs, MCIP is working with the OTs to identify the key climate change issues they are facing and amplify the messages around these topics at COP26. An expert scientific review of available evidence on these issues has been undertaken. This will be used to summarize in easy-to-read report cards. The aim is to use the MCIP model that has been very successful in the mainland UK to build climate change baselines and networks in the UK overseas territories. This provides an opportunity to highlight these issues that are important to the OTs ahead of COP26. Rather than working on each territory, they are grouped by region as climate drivers and impacts are likely to be similar. This also prevents duplication of effort and increases the chances of covering the data gaps. There are 6 regional working groups were created, and these comprise a scientific chair who is an expert based in the region, plus selected regional scientists. The regional working groups were responsible for identifying the priority climate change issues, compiling the available evidence on those issues, and authoring the scientific review. Reese Hobb from St. Helena led the South Atlantic region and who I've worked with in compiling the report. The project received high-level steers from the Overseas Working Group who set priorities for the work, ensuring that scientific integrity is maintained and that the outputs are relevant for all the stakeholders. Throughout the process, MCIP has acted as a facilitator for the OTs to discuss their climate change concerns. MCIP's aim was to give ownership to the territories, ensuring that the outputs were in their voice. To achieve this, the Overseas Working Group included representatives from UCATA to ensure that the OT priorities are being met by projects, also including reps from the Blue Belt program to facilitate collaborative working across the OT's marine programs. As much as possible, the regional working groups comprise scientists and experts from the territories themselves, ensuring that every territory had the chance to input directly. They provided the scientific consensus and evidence that formed the scientific reviews. There were facilitated workshops for each of the regional groups to identify the key climate change issues affecting the OTs in their region and which they would author the science reviews. Nothing was constrained. The participants were free to suggest new issues, tailor them to their particular regions, and all the outcomes were open to extensive discussion. Everyone tried to ensure that the selected issues were balanced, best represented all the OTs in the particular region, and yet sometimes this is more challenging as in some regions are geologically dispersed and each OT is unique. And all scientific content is peer-reviewed and report card outputs are reviewed by each regional working groups. The outputs and next steps include a digital climate change report card is being produced for each regional group with the key messages drawn from the regional scientific review papers. An overarching UK OTs and climate change infographic is currently being produced. This will draw together the work from across the 6 regions and highlight common climate changes faced by the OTs. By drawing together the evidence on a diverse range of climate change issues across the OTs, it is generating a baseline for future UK OTs climate change work, as well as highlighting where the data gaps exist. The project has also created 6 completely new networks of marine climate change experts in the UK OTs and is building engagement with climate change issues across the territories. The outputs will be officially launched at a virtual event in the coming months, where the focus will be given to the regional working groups to showcase their messages. This work will also be promoted at COP26, helping to amplify the UK Overseas Territories' climate priorities. There were also concurrent Blue Belt projects going along with MSIP. This is talking about a Cefas-led climate change impacts on corals in Biot and Pitcairn. A review was undertaken by Cefas and other partners in order to compile the latest scientific information on current and future drivers of climate change in the marine and coastal environments of the UKOTs of Pitcairn and Biot. This is to understand the risks to the corals of these territories, as well as other important marine life. The result was a backing paper and a report card that was published in March of this year. There are several climate change impacts in Biot, including acidification and increases in sea temperature, which will lead to coral decline with marine heat waves resulting in bleaching and shallow reef habitat loss. There's also concerns of sea level rise and erosion impacts. Onward from this project, they'll be looking at developing management plans to help reduce human pressure from fishing and anchor damage. Just as in Biot, there was also looks at temperature changes in Pitcairn. As you can see in this slide, there's been past thermal stress in the islands with the annual 2-degree heating weeks from the 4 main islands. Pitcairn, unlike Biot, has deeper corals below 30 meters, so there's less impacts of warming surface temperatures, but still risks from ocean acidification. Work also showed decreased pH levels will lead to calcium carbonate minerals that will be too low to support calcification. Also, like Biot, impacts from sea level rise to lower level corals on the islands of Henderson and Ducie. More work is needed to look at current and atmospheric processes on the South Pacific Circulation Gyre. Moving from the Pacific to the Atlantic, additional Cefas project was looking at Tristan da Cunha and climate modeling. Climate change model work happened in Tristan da Cunha and St. Helena on Tristan rock lobster and tuna species found in St. Helena. Variables modeled were depth, temperature, and salinity. The models look at environmental conditions where the animal is now, and then project those same variables into the future to see where the suitable habitat will be. The results were that Tristan waters were still suitable for lobster and southern bluefin tuna. This is really important because lobster is the main economy for Tristan da Cunha. Work also helped with the Tristan Marine Protection Zone designation and the lobster fisheries management. It also contributed to St. Helena's Marine Management Plan and yellowfin tuna data gaps. To wrap up, an example of OTs using science for management decisions and potential climate change links. The first statement is from 2015, when Tristan joined the Blue Belt program. And after working with Cefas, other government agencies, and NGOs, this has led to the Marine Protection Zone declaration in last November. Tristan's MPZ is almost 700,000 kilometers squared, just about 3 times the size of the UK. It is the largest no-take zone in the Atlantic Ocean. It's the 4th largest in the world, and current projects for blue carbon and kelp monitoring are ongoing. There have been lots of talented people involved, including from Cefas, and the community has been grateful for all their hard work contributing to the MPZ decision. As we like to say, small islands, big impact. Thank you so much for listening.
Hello all. Today I will present to you one of the communication outputs from the Cefas JNCC Collaborative Project investigating climate change resilience of vulnerable marine species around the UK. Our goal was to take complex, technical modelling outputs and present them in a way to inform the public of how valuable research like this is in protecting the UK's seas. Cross-organisational working such as this can tackle the shared problem of considering climate change in the context of marine environmental decision-making and support the UK's statutory commitments. We very much hope you enjoy. The resulting change to the suitable habitat for each species are predicted as increased or decreased suitability around the UK. The RCP 4.5 scenario projects that UK waters will become gradually more suitable for oyster settlement, beginning with seas off the south coast of England and progressing north into the Irish Sea. By 2099, the southern North Sea and the seas off the west coast of the UK will also be more suitable for the native oyster. The RCP 8.5 scenario projects that UK waters will become increasingly more suitable for oyster settlement between now and 2099, beginning with seas off the south coast of England and progressing north into the Irish Sea. By 2099, almost all of UK waters will be more suitable for the native oyster. Overall, native oysters are a species likely to see one of the greatest increases in suitable habitat, with the southern North Sea and the seas off the west of the UK showing particular increases under both scenarios.
Hello, my name is John Pinniger from the Cefas Climate Change team, and I'm going to talk about risk and resilience in the hottest sea on Earth. This is a project carried out together with an organisation called ROPME, the Regional Organisation for the Protection of the Marine Environment. This is the regional seas organisation that covers the area around the Gulf, the Straits of Hormuz and the coast of Oman. ROPME has 8 member states, and these are Kuwait, Iran, the United Arab Emirates, Qatar, Bahrain, Iraq, Oman and Saudi Arabia. We were specifically asked to help them to put together a marine climate change risk assessment because of our previous work on the UK climate change risk assessment, together with one in the United Arab Emirates. And today, on the 16th of June, the UK is launching its 3rd climate change risk assessment. So what did we do? Firstly, we reviewed the evidence and everything that we could find on climate change in the ROPME Sea area and produced a very large evidence report. Then we convened a panel of 16 technical experts and we held a meeting in Oman where we scored those risks. So we started with a long list of 15 risks to biodiversity and 30 risks to economy and society. And we scored them on the basis of proximity, so how soon the effect will be felt, and magnitude, so how big the impact will be. So a little bit about the region. So temperature. The ROPME Sea area is already one of the warmest seas on Earth, and regularly in the inner ROPME Sea area exceeds 36 degrees C. And in terms of sea surface temperature, the anticipation is that we're going to see between 2 and 4 degrees C of temperature rise in the next 50 to 60 years. It's also a relatively salty area. The high evaporation rate leads to very saline waters, and salinity has increased by about 1% over the past 60 years. In terms of ocean acidification, we're already seeing a decline in the pH of the waters of the area, and the expectation is that the pH could decrease by about 0.25 pH units over the next 20-30 years. And this might not sound a lot, but that's actually quite a large increase in acidity. The area is also known for very large low oxygen zones or oxygen minimum zones, and these are expected to become larger and more persistent in the future. Cyclones and storms. The coast of Oman is typically hit by a cyclone about every 5 years, and the expectation is that this will increase towards the end of the century. The area is also affected by the Indian monsoon, and although the relationship is weakening, this could affect rainfall patterns in the future. And finally, sea level rise. Sea level has been rising by about 2 millimeters per year in the last 50 years. So what are the results? So these are the 12 most severe risks that we identified affecting the ROPME Sea area. And the 2 that came out with the highest scores that you can see in red are damaged coral reefs and harmful algal blooms. And this is largely because these are already occurring on a fairly regular basis. Then there were 6 risks that came out with fairly high and severe scores, mostly around infrastructure and livelihoods, so lives in people, fisheries, flooding in infrastructure, desalination plants, energy and industry, and disruption to transport. And finally, there were 4 severe risks which are mostly biodiversity focused on plankton productivity, coral health, jellification, which is the proliferation of jellyfish, and the impact of low oxygen on shell fisheries. So these are the 12 most severe risks that we identified in the Rottnest Sea area, the hottest sea on Earth. Thank you, and if you're interested in our report, please scan the QR code.
This talk is about what we can actually do about climate change, with an example about fisheries adaptation in the Caribbean. So climate change is already impacting Caribbean fisheries, and it's expected to get worse. It's causing declining stocks and degrading habitats. The Caribbean is hugely reliant on fisheries for both food and culture, and so small-scale fishers really need tools to adapt. Cefas has completed a project under the Commonwealth Marine Economies Programme, and alongside regional partners. We produced a report card which summarises the actions to be taken in the region to make the fisheries sector more resilient to climate change. Report cards are short documents which summarise technical information in a way that's easy to understand and easy to share, and are aimed at providing information to those who don't usually have time or access to scientific papers. The report card is also supported by a longer peer-reviewed document which contains the evidence base and research that supports the report card. So in the report card, actions to be taken are split into short-term actions and longer-term goals. There are short-term actions at the local scale, and many projects are already underway in the region that can be replicated elsewhere without a lot of time or money. And these are local scale on the ground actions that fishers can take. Examples include improving safety at sea and developing disaster management plans, or moving to more sustainable pelagic fishing away from reef fishing. There are also actions that cooperatives and managers can take, and these actions are the first steps to overcoming the reliance on overfished stocks and improving the health of the marine environment. Examples of these include rehabilitating degraded ecosystems locally and building adaptive capacity among fisherfolk. And longer-term goals are other adaptation actions that require more funding, research or policy change to implement, but will have a larger impact on the sector. So these examples would be moving towards ecosystem-based management of fisheries or large-scale restoration of ecosystems. So the headline messages to come out of this report card are to continue what works, because action has already started and is making a real difference to lives and livelihoods. Also to collaborate and engage. Fisherfolk should be involved in adaptation at every stage to ensure buy-in and build capacity within the sector. Individuals and communities in the Caribbean are encouraged to get involved in adaptation and management to drive the development of climate-smart fisheries. And lastly, to study and act, because targeted research can help managers to facilitate change through assessments of fish stocks, social science and economics. So please have a look at the report card and the backing paper on the gov.uk website. Thank you for listening, and also thank you to the partners who are involved in this project.
Thank you so much to all of our speakers in this afternoon session, and it's great to see all of our science having such strong outcomes. We've now got a 10-minute break and another opportunity to watch our Blue Belt video. If you've expressed an interest in one of our focus discussion groups, then you can join that using the Microsoft Teams invitation that you've already been sent. And just as a reminder, there's 5 sessions, one on Blue Belt, another on forensic oceanography, a third on a day in the life of a research vessel, there's a session on our Fish Health Inspectorate, and finally a discussion on the work of the Plankton and benthic teams. If you still want to join any of those, then do look at the email that came in this morning, and there will be links in that email to any of those that you wish to join. Otherwise, stay online and watch the Cefas PhD student talks again. But as before, please don't copy or tweet the words, because some of the work is still in review. And then after all that, we'll come back together in this live events link at precisely 5 minutes to 3 for our final keynote talk. Thank you all.